Today we are doing hard problem 220 contains duplicate 3. We are given integer a nums and two integers index diff and value diff. And we need to find pair of indices such that they are at most index diff apart and their values are at most value diff apart, and return true or false if it exists. So my idea is that, first of all, what are the constraints on the length of the array, and second on the values. Okay, it's 10 to 5 and 10 to 9. So, okay, idea is this. Let's pretend. So index diff difference means there is 2 times index diff minus 1 window, which we slide, and we just want to check if there is two values close enough together. Now let's say we have the values sorted, right? We have a multi-set of values, and then for each value in the window, right, we go through, so we create window, and then for each window, for each value in the window, we check if there is something, we find it with lower bound, which is binary search, because that's like a balanced tree, and then we check previous and next element, like previous and next iterator, and one of them, if either of them is close enough to the value there, great, we just we return true, right? Otherwise, if nothing happens for the entire window, we remove first element and add last element, and that's it, and we do again for whole window. I think that going through the entire window at each position, hopefully will not be bad. I hope, because what's worst case? Let's say you have window of half the size. Nah, that's bad, right? If you have window that is half, this is n half, then you move that n half times. So n half times, you go through n half and you suddenly got n squared. So that's not good. Oh, of course, you just check the new value edit, right? First we check the entire window, and then we just check each new edit value only. Of course, because why would we check? It's symmetric, so if something new would come up, it would come up with the new value inserted, of course. Okay, so let's try to do that. Multi-set int window, and then for int I, let's make a variable k, which will be 2 times diff minus 1, and then we do less than ki plus plus window. Actually, I don't have to first insert the window. I can do this. Window, insert, window insert nums I, if I k, window erase nums I minus k, and then we want to check, so auto iterator is window lower bound on nums I, right? And then we do if it doesn't equal window begin, right? So if we are not at the end, and nums I minus previous iterator is less than or equal to value differential, then return, right? Other check, if next it doesn't equal window end, and next it minus num xi less than value and then we return false if nothing happened, and this should work, I think. Let's see. Time limit exceeded, what do you mean? Oh, erase. Yeah, because this erases. Yeah, the erase always causes problems for some reason. If you are erasing from multiset, it's confused about multiple occurrences. Should pass. Holy. What should be the size of this window? If it's 1, if it's 2 to both sides, then it's 2 times, so it's 2 times index diff plus 1. See, that's the problem, and it's still passed 44 test cases. How is that possible, bruv? What is that? What? So, num xi. Nah, that's weird, bro. Nah, that's weird. That's weird. 1591. Let's see. Zero, 1, 2, 3. Well, I mean, yeah, it's not great. So actually it should be this. Yeah, that I didn't work that out. Basically we just want to look at past index diff characters. Well, then this doesn't work. Hmm. 113 happens in first one. Yeah, that's exactly the problem, because like this. What the hell? If I 0, 1, 2, right, then salt num xi minus answer should be -1. Okay, this should pass finally. Great. Okay, that wasn't horrific. Okay, symmetry plus ordered and log n. So suppose we have previous index diff numbers including the current one in a ordered multiset. We simply have to find the previous and next values of current number and check their difference. Then we erase the number that first we also have to erase the number that is too far, that is more than index diff in the past, e.g. we erase nums I minus index diff -1 if I index diff. We can do this in O log n with multiset erase multiset lower bound to avoid TLE with just multiset erase due to multiple occurrences. Okay, since multiple occurrences causes std multiset to shit its pants. O n log n, where n is the size of nums, since on inserts and deletes, which are both O log n operations. Complexity is not that space, since we have at most at all times. Great. Post dopamine inducing heart problem because I solved it in what, 10 minutes. Okay, see you tomorrow.